Hey everybody, welcome to the second video in our tutorial series on beginner game development in Unity. So in this video we're going to talk about a couple different things. We're going to start off by talking about something called scope, which is a concept I didn't get a chance to really dive into in our last video. And then we're going to add just a few little effects to our game and add a couple little things to it just to try and spruce it up and demonstrate some more basic concepts. So first things first, let's head into our Visual Studio code editor here and see what we can do. I want to talk about something called scope. So what is scope? Well, basically it just talks about the visibility of variables and methods depending on where you declare them. For example, here we look at our class. It says public class character control. This is our class right here. And you see before we declare any methods, we have these two variables at the top. These are called class variables. And they're called that because they can be accessed by any method within this class. So you see here we have jump strength declared up here, and we can access it down here in the check for input. Same thing with isGrounded. We can access it in methods that are within our class. Now if I was to go into this check for input thing and put int x equals 0, right? That's perfectly fine. That's a local variable. Now we can't access this from anywhere else other than inside here. So for example, update won't see it. I can't use x here. X equals, the IntelliSense won't pick it up because it's in the wrong scope. Same thing down here. These two methods will not see this variable at all, but this one will because it's declared within the scope of this method. So if you need to use variables that all of your different methods might need to pull from, put them in the class. If only the method needs to use it, put it within the method itself. You'll find it keeps things a little bit cleaner. And when it comes to methods, once again, back to the whole public thing and private thing. Right now, the check for input method, for example, is private because we haven't specified the access level, so it defaults to private. But if we put public here, we've just changed the scope of it. So what that means now is another script can reference it. So we can, in some other script entirely, we can reference character controller dot check for input because we made it public now. So that's one way to change the scope of your methods if you need to. That's just the basic concept of scope. I hope that was relatively clear. It's not a super difficult concept, but it's a very important one to sort of grasp early on. Alright, let's head back into our Unity and see what kind of effects we can add. So let's run our game and see where we're at right now. So basically, for the time being, we have our green dude going back and forth, and he can jump onto the other platform, and it's all good. But you'll notice something kind of weird, oops, as I fall off and die. But basically, you'll notice as we move back and forth, left and right, he's always facing the same way, and it just doesn't quite look right. So what we'd like him to do is, if he's moving to the left, we'd like him to turn around to the left, and if he's moving right, we'd like him to turn right. So how do we do that? Well, let's go ahead and click on him, and look at his properties real quick. In his transform, the first sort of component he has here, you see he has a position value, a rotation value, and a scale value. Now you'll see X, Y, and Z. This position is what's called a vector 3. We mentioned those in our last video. So it's a vector 3, so it stores 3 bits of info, an X, a Y, and a Z. So that's where the 3 comes from the vector. So vector 3, 1, 2, 3 little spots for data. And so each of these are vector 3s. They all store an X, Y, and a Z. So this is where his position is relative to his parent. So right now, you see here, the player doesn't appear to have a parent object, but in fact it does. The parent object for this player right now is the scene itself. For example, if we were to right-click on this and say create empty, well now this game object here is, you see how it's underneath the player in the hierarchy? That's saying that the player is a parent of this game object, right? And then if we move the player, the child object will move with it, and so on. Now we can move the child object out to here. We can just give it a little picture so you can see it. And if we move this, the child moves with it, but the child does not dictate where the parent goes, kind of thing. So that's sort of another little concept that I never got around to explaining in the last video, but that's basically how sort of parent-child relationship works. So by that same token, this player object is a child of the sample scene, as you see, because he's sort of to the right underneath, if that makes any sense. So when you look over here in these numbers here, this is his position relative to his parent. So he's at -3, 2.49, and 2.26 or whatever. If we were to zero that out, so this is working from the middle. Let's go ahead and put him back where he was over here. So he also has a rotation value, which we can sort of spin him around if we want to. But also he has a scale value, so he's got an X scale and a Y scale. So if you remember, X is on the horizontal and Y is on the vertical. So if we want him to look to the left, well, watch what happens when we pull his scale down. And he flips over. You see that? So his regular scale is just 1 on the X, but if we make that -1, watch what happens. Now he's looking the other way. So all we have to do in our code is whenever we press the left button to go left, or whenever we're getting left input, we want to set his X scale to -1, and vice versa when he's turning right, or when we're pressing right rather, just set the scale to 1. Simple, simple. So how do we do that? Well, let's go ahead in our code and have a look. So here we have in our check for input, we're seeing where we're getting the access raw data, and we're changing, we're putting the force here, but we can also do a separate thing here. So we can put in another little if. We can say if input.getAccessRaw, if I can type today, horizontal, and we're already checking that it's not 0, so it has some kind of value. So we're going to say if this value is less than 0, this means left. We talked about that in the last video. If the value is negative, that means it's to the left, and if it's positive, it's to the right. So what do we want to do? We want to set his X value local scale to -1. So what we'll say is transform.local scale, local scale equals new vector 3. Now, here's a little aside real quick. What you cannot do is this. Transform.localscale.x equals some value. You can't do this. Like if you go -1, it's going to snip at me. Because you can't, the member variables within local scale are not, they're not really variables. It's just part of a larger variable. So you can't change one part of a vector 3. You have to sort of change the entire vector 3 at once. So we can't say this, but what we can do is we can say transform.localscale equals new vector 3 and simply set the whole thing. So X, again, as we said, -1, and then the Y is still 1, and the Z is 1, unchanged. Just like that. And by the same token, we can put the exact same logic if he's going right. If the scale is bigger than 0, that means we're going right. So now we set it back to 1. And that's it. Let's have a look at what that looks like. So now you see as we move around, we're turning. Now you see we're actually bouncing. We're turning and we're rotating, which is probably not optimal. Let's go ahead and fix that right away. It's kind of funny looking, but that's not what we want really. Maybe it is what you want, but in this case, we don't want it. So what we're going to do is we're going to go into our rigid body of our character. We don't want him, you know, falling over like that and rotating. So what we can do is we can freeze the rotation on the Z. So you got to remember, this is the Y-axis, this is the X-axis, and the Z-axis kind of goes into the screen, if that makes sense. It's the third dimension in this 3-dimension. So we want to rotate, or we want to forbid any rotation around that axis, and that axis is the Z value. So we can freeze his rotation on the Z, so that won't happen anymore. And as you see, he looks left, looks right, based on where he's going, and it's all good. Alright, so let's see if we can add a little bit more functionality to this game, some more features, and see if we can showcase some more stuff. So let's go ahead and add another platform. So we'll go into our prefabs folder, we'll grab that platform prefab and drag it out. I want to create an old effect you used to see in those old NES games sometimes, where you can kind of jump up onto the platform from below. So right now, I'll show you what I mean. We'll go ahead and run that. And right now, we can't really get under it. We want to be able to jump up underneath it, like from underneath it and land on top kind of thing. You used to be able to do that in old NES games, so let's try and replicate that here. But unfortunately, we can't do it. So let's solve this for a second. Let's raise it up a little bit higher so we can get underneath it, and I'll show you what I mean. We might have to increase our jump force a little bit to demonstrate this properly. But so now you can see we can get underneath it, but we can't get through it, right? So there's a way to do this. So what you want to do is you want to go into your platform. Let's do it in the prefab to make it all good and make it all cascade over. So there's a component you can add called a platform effector 2D. So we're going to go ahead and add that. And what that does is allows you to set it for a one-way trigger, which is exactly what we want. And so you're going to see a little error here when you add that component. This effector will not function until there is at least one enabled 2D collider with used by effector checked in this game object. So you got to go up to your box collider, and then there's going to be a little thing right here, used by effector. So go ahead and click that, and then you'll get this sort of little half circle thing, which you can change the angle or the arc of it or however you want it to work. 180 is appropriate for our purposes right now. And then you probably want to take this collider and make it a little bit more forgiving like this. We can actually get underneath it without putting it too low. We'll go ahead and do that. And now we can probably lower the whole thing down just a little bit, so it's a little more forgiving. And now let's go ahead and see what that looks like. You can kind of go underneath it and hop up on top. So we have our cool platform effector now, just like in those old school games. So that's pretty cool. Of course, you are noticing that he's going behind it, and maybe that's the effect you want, but today we're going to go ahead of it. So let's change our sprite order here. Right now, if we look at this platform, we're outputting to the default layer, order in layer 0. So if we click on our player, he's also outputting to the default layer. This is in our sprite renderer component. So the sorting layer is default, but the order layer, if we put it to 1, that's going to put him in front of the thing. So the higher numbers go in front. So if we try that again, now you see he's in front. So now that we've got that figured out, why don't we add a few more platforms? And we can put like a power-up or something at the top for you to collect kind of thing, right? So let's just drag a couple more of these platforms, and we'll get our little dude up here, and we'll put some sort of a power-up at the top here. And we will, of course, have to move our player away. Maybe we'll put him in a more sensible spot like that so he can work his way up and then grab the thing. Now for the actual power-up, I don't have anything prepared for that, but what I can do is I can just use a default sprite, so that's no big deal. So what we'll do is we'll go ahead and create a new game object in our sample scene. We'll create an empty object, and to that we're going to add a sprite component. So sprite renderer, like that. And now the sprite we're going to use, there's some things that come with Unity, just these little pointless sprites. We're just going to use this one. It's called mob, just a little circle, whatever, it doesn't matter. We'll scale it up a little bit, make it a little bit bigger so we can see what's going on here. We'll make it blue. There we go. Blue is a power-up or something, right? So there's our power-up. And we also need to give it a collider as well. So let's go ahead and give it a circle collider, because that will more or less match the fact that it's a circle. So what we're going to do is put that collider in there. That way when our collider on our object, or on our player rather, connects with this power-up, it will trigger something. Now we don't need a rigid body or anything like that on this. We don't want it to give it any weight or any mass. But just for the sake of demonstration, let's do that anyway. Let's give it a rigid body. Rigid body 2D. We're going to delete this after, but this would be a fun way to demonstrate the point of this. So we're going to give it a bit of mass. We're not going to have it affected by gravity. We want it to float there, but we want to see what happens when we bump into it. See, we can jump up, and boom. So we just whacked it like a beach ball, and it floated away. And that's because we gave it mass and a rigid body. So that's what happened. So the mass of this guy slammed into the big beach ball and sent it flying. And because it's not affected by gravity, it didn't fall off the edge. It just kept going like it was in space or something. So we don't want that, but that's just kind of a simple demo of what this sort of does, right? So we're going to go ahead and get rid of that. We don't need that on there. But what we do want is for it to do something. Maybe it gives us points or something, right? So why don't we do that? So the first thing we want to do is we don't want to actually smash into it. We just want it to trigger something. So this little thing here is trigger. That just means we don't want the two things to like collide and smash into each other. We just want it crossing that threshold so it sends off a trigger. That's all we want. So we just want to set is trigger. Now what we want to do is we're going to go ahead and put a script on this ball to make it do something when we trigger it. So we're going to make a new script. So let's add a script to our ball here. We'll call it blue ball. That was not planned. And what we're going to do is we're going to get rid of all this stuff here. We don't need an update method, and we don't need a start method right now. So what we're going to do is make another trigger events, just like we did before with the collision events. So we're going to say void on trigger enter 2D. So this is the trigger we set up. So because we set it as a trigger, we have to say on trigger enter as opposed to on collision enter 2D. So whenever we trigger this, we're going to go ahead and do something. So what do we want to do? Well, we probably want the ball to vanish, or maybe provide some points to the player, and then vanish. So what we'll do is we'll put a print statement in for now, and then after we'll actually implement the idea of giving the player points or something. We'll get to that. But for now, we'll just put a print statement. So we'll say print giving player points right there. And then what do we want to do? Well, once the player gets the points and collects the power-up, we want to get rid of the power-up, right? So what we want to say is there's a command called destroy. And as you can imagine, it's going to destroy. So what's it destroy? So when we do the IntelliSense thing here, it's kind of like an autofill. This is what Visual Studio does. One of the reasons it's really good. Destroy object. So we need to destroy something. What do you want to destroy? We want to destroy ourselves here. Just destroy the game object that's attached to the script. So we want to say this.gameObject. So that's going to destroy the game object that is attached to this current instance, right? So once we trigger, it's going to print to the console, giving player points, and then it's going to destroy itself. So let's give that a try. So we can hop up to the top here, if I can manage, and boom, we collect the ball, and it says giving player points. So it works. So how do we actually store the points, and how do we display them on the screen to indicate that we are in fact gaining points? So it's quite simple. What we're going to do is we're going to go into our player object, and we could put it in the character controller script, but let's be a little more clean about it, and let's add a brand new script to our player. We'll just call it, I don't know, player script or something, right? And we'll open that up in Visual Studio. We're not really going to need an update function for this because we're just trying to store data here. So what we'll say is, and as you remember, this is going to be a class variable, so any method in here can use it. So we're going to say int player points, if I could type today, equals 0. And we're going to initialize it to 0. Now you'll see I'm not putting an F in front of that or after that 0 because it's an integer. Integers are just whole numbers. We're not going to deal in decimals for the player's points, so we don't need to worry about it. Alternatively, we could do something like int player points, and then we could initialize in here and say player points equals 0. And this is going to execute before the first frame update. So we'll initialize our points to 0, but either way, it doesn't matter. But we've forgotten to do something. We want to put public in front of this integer, so now other scripts can access this value. So when the ball gets our, when we collect the blue ball at the top, it needs to be able to access this variable to add points to it, right? So we need to expose it and make it public. Okay, so now that we're back in Unity, what we can do is we can edit our ball script once more. And this time what we need to do is another really important thing for Unity, and it's called object references. So we need to get a reference to this player object from within the ball object so they can communicate and send information back and forth. So once we're in our script, what we want to do is create an object reference, and this is how we do it. We say public game object, we'll call it player object, or maybe player, that's it. Now, what that's going to do, if you recall from before, that's going to open up an exposed field on our Unity side. So on our script here, if we give it a second, there you go, player. So we've declared a variable called player, a public one, and we've made it of type game object. So you see here this input field says none, in brackets game object. It's expecting a game object to be put in there. So there's a couple different ways we could do object references. The first way we could do it is we could go into here, oops, wrong one. We could go into here and we could say on start, void start. What we could do is say player equals game object dot find player object, or whatever we called it. We could do that. That's one way to do it. You'll hear here and there that using this find is not a good idea. I've never had any trouble with it myself, but it is a little bit expensive on terms of performance. You wouldn't want to do this inside your update method or any kind of loop. I think doing it on its own like this is probably fine. I've never had any problems with it, but there seems to be a general wisdom not to do this. So if you don't want to do this, that's totally fine. You don't have to. There's another way to do it, and it's arguably simpler anyway. You can't always do it. In certain situations, you sort of have to do the find thing, but we're going to do it this, quote, proper Unity way right now. So you see here, blue ball script, player none, right? So it's expecting a game object here, so we want to put the reference to our player object in here. So we can literally just grab our player object and drag him into the slot. And that's the sort of standard, proper way to make an object reference in Unity. So now, this player object that I just dragged in there is going to be in this spot right here. Game object player, that's now equal to what I just dragged into that spot. So what do we do with that now? Well, now that we have our object reference, we can get rid of this print statement, and instead of printing giving player points, we can say player.getComponent player script, because player is the game object. We're getting the component on that object called player script, that script we made. When you add a script to a game object, it just acts as a component, so we can say getComponent player script, and you have to put the two brackets after the thing here, after the component, dot player points plus equals, say, 50. So we'll give the player 50 points every time he picks up a blue ball. Another thing we can do is we can expose the amount of points. So we can say public int points value or something, right? And then we can add points value down here. That way we can change this value in the inspector, not have to come into the code every time and change it. Now you'll notice this strange operator here, plus equals. What does that mean? Plus equals is short form for saying something like player points is equal to player points plus 50 or whatever. You know what I mean? It's basically player points is equal to player points plus value. That's what that's saying. It's just a short form. You could say minus equals, and this will subtract points value from player points, but we don't want to do that. We want to award points. So there we go. Now, if you want to test it, we could say print this right here. We could say something like the player now has, and then plus points. So the way you structure a print statement is you can do this. You can say, you can put it a string here, and you have to use the sort of quotation marks, and then you can add a variable in the middle of it. You put plus, and then the variable you want to print in there, and then you put another plus, and then another string, or however you want to do it, and that'll spit out the debug. So let's check what that looks like. So if we keep our eye on the console here, we can go up and collect our power up. If I can, and then boom, the player has 0 points. So that failed. And why did that fail? Because we never set the point value. So let's go ahead and set it right now. Let's give it 50 right here. I just forgot to type it in. Do that again. Back up on the platform, if I can, and boom. The player now has 50 points. So that's a super simple way of keeping track of information, awarding points, and that's how you make object references so that the different objects can talk back and forth. It's a very, very important concept to learn. It's not super complicated, I hope. I hope I didn't make it too complicated, but it's actually quite simple. Now, one last thing we'll do in this video is we'll look at a way of displaying those points. Let's go ahead and do that. So what we want to do is we want to store the points in a spot on the screen that's independent of what's actually happening in the game, because all this stuff's going to be happening in the game, but we want a kind of like overlay on top of everything so that that's completely unaffected by anything going on in the game. It's literally just you have the game in the background and you've got this overlay in front of everything that stays the same, or updates whatever you need to, but it's not affected by the game itself. And so to do that, we're going to create a new UI, and we're going to go down to this thing called canvas. So a canvas is exactly that. It's an overlay on top of your screen, and you see it made this square here. If we zoom all the way out, this is our screen right now. So this is the canvas, the way it looks. Like if we go in and zoom in here, you might think, well, this is our screen, right? Well, that's the game view. This is put over here. I'm not sure why they put it over here, what the logic is there, but this is basically our screen, like our monitor, if that makes any sense. So if I put, something on the canvas over here, it's not gonna, it's still gonna be in the scene. It's just gonna be like, if we're looking at it, it would appear more or less here, if that makes any sense. So we're gonna go ahead and add a value, a text component to this canvas, just to store our points so that we can see them on the screen when we play. So under our canvas, we're gonna add another UI element called text. Now, a lot of people favor this Text Mesh Pro. It's like text, but it has a little bit more functionality. You can do like 3D stuff with it, I think, and different effects. That's completely unnecessary for us. We can make nice, clean, crisp-looking text just with the basic default texting. So, just to demonstrate real quick, we have this new text component here, and if we move it over here, say, you'll see that it's in the corner, and it looks like it's nowhere near our scene, but if we actually run our game, you'll see that it is in fact in the top left corner. So it sort of overlays that canvas on top of, you know, whatever we're doing, right? But you'll notice it looks kind of blurry. So what we can do to fix that, and a lot of people go to Text Mesh Pro to fix this problem, but I've never had to. So what you can do is you can just do this, crank up the font size. You'll have to make this box bigger to accommodate. But now you might think, well, that's way too big. Well, then you just scale it back like this. So you keep the crispness of the text and just make it smaller, right? So that's just a little workaround I found that you know, people don't seem to clue in on, or maybe they don't care, or maybe they just really like Text Mesh Pro, but I've never felt the need to use it. So this is how I do it. So we have a little text component there. So what we'll do is we'll go ahead and rename this for readability. So we'll call it txt player points, if I can type. Let's maybe change the color of it so we can see it a little better. We're on a blue background, so maybe we'll go bright red. I don't know, bright red, but we'll try that. Arial's not the greatest font, but I don't really feel like changing that right now. I don't feel like going to get another font. Now, another thing you can sort of do here that you might consider doing is if your game is played on different size monitors and things like that, or different size screens, you don't want this floating all the way around the place, because right now this little X in the middle, that's saying that this text object is at these coordinates relative to this point in the center. So it's negative 542 on the X up from the center, and then it's up 258. So normally that's not necessarily a problem, but the problem is, if you, like I said, if you're running into different screen sizes, you might not even see this text, or it might appear closer to the middle in a much larger screen. So what you can do is you can go up here. This is the anchor point, so the anchor presets. Right now we're set to the middle of the canvas, and we don't want that. We want this to be a certain distance from this. That way, no matter how big or small the screen is, this text is a certain distance from this corner. So if we change this to that, you'll see as I did that, the X and Y coordinates changed. Again, those are relative to the parent, and I should say relative to the anchor point on the parent. And right now the anchor point on the parent is this canvas point at this corner here. So now, regardless of the size of our screen, it will always appear this far away from this particular corner. Just a little random tip you might find helpful. Alright, so now that we have that, what we need to do is get a reference to it. So let's get a reference to it in our ball here. And the reason we're going to get a reference to it in the ball is because we're incrementing the points from within the ball. So it's just a simpler place to put it. So we're going to go back into our ball script here. And wherever we put points, we're going to go ahead and update the text value. So what we're going to do is we're going to go ahead and declare a new public object. So public text player points text, or something like that. Now you'll notice it's giving me an error here, and if you hover over, it'll say type or namespace text could not be found. Are you missing an assembly reference? Well, we are missing an assembly reference. So what we need to do is go up here to our assembly references that we talked about in the other video, and type using Unity Engine .ui. So this UI namespace holds all the different data types for things like canvas variables and text variables and things like that. So we need to include this in order to tell Unity what we're doing here, because without it, it had no idea what I was talking about when I said text. But once we include it, it's all good. So what we can do is we can go ahead and put the start method back in now that we need it. And we can say player points text equals gameobject.find txt player points dot get component text. Oops, if I can type again. So what we're saying is we want to find the object called txt player points and reference the text component of it, because again, this is just a game object with all manner of different components on it, but we want to specifically access this text component, and that's what we've done over here. Oh, wrong one. Over here. So now that we've done that, what we can do is we can say player points text.text equals, say, points plus player.getComponent player points. And we don't need this print statement anymore because it's going to be kind of explicit. So we can get rid of that. Now what we probably should do before we run this is we should probably initialize the text field to say points in the beginning. That way, you know, it says something at the start. So what we'll do is we'll just say, we'll just initialize it to points and then 0, kind of like that. So let's see what we get here. See, it says points 0. Let's see what happens when we pick up the blue orb here. Boink, points 50. And so no matter where we go in the scene, no matter what happens to the camera, this will always be in the top left. And that's how the canvas works. Now there's obviously tons of other stuff you can do with canvas variables. You can make health bars, you can make little readouts, you can make UI elements, buttons, whatever you gotta do. But that'll probably come later, I think. I think that's gonna pretty well do it for this video, guys. Hopefully you found that helpful. If you did, let me know in the comments below, or if there's anything else you wanted to see, definitely let me know as well. But I think we're gonna wrap it up there. So as always, thanks for watching. I hope you found it helpful, and we'll see you next time.